So let's talk about the rules that go with the sum of our interior and exterior angles. All right, now let's start with the interior angles. Now we already know the sum of our triangles, our three-sided figures, is 180. All right, we learned in the last video that the sum of all quadrilaterals will always be 360. But what if I have 20 sides? What if I have 150 sides? How do I figure out what the sum of those shapes should be? And there is a formula. All right, the sum of the measures of the interior angles of any convex n-gon, and this word I should emphasize, convex, okay? We can't have the vertices kind of sinking into our picture. They have to all be pushed out, and you must be working with a convex polygon. But the formula is 180 times n minus 2. N is the number of sides, which would also be the number of angles. All right, so if you happen to know how many angles there are versus the number of sides, okay, then you can use either one of those to represent your n. Now the second formula, because you're going to do problems that ask you for the measure of each interior angle. So we've got the one formula for the sum, but if we wanted to find each interior angle, and notice it has to be for a regular n-gon, which means all the angles have to be the same. Then we simply take our sum, 180 times the quantity n minus 2, and divide by n. All right, so again, take the sum and divide by n, the number of angles or the number of sides. They will always be the same. So the trick to these is, as you read, is to find the key words. Are you being asked to find sum, or are you asked to find each angle or maybe each side? Number one, it says find the sum of the interior angles of a convex octagon. So that means n is going to be 8. And I want the sum. So I'm doing this formula, 180 times n minus 2. So I'm going to fill it in with the 8. So 180 times 8 minus 2, all right, is going to be 180 times 6. And then 180 times 6 is going to give us 1,080 degrees. All right. Now, number 2 says find the measure of each interior angle of a regular, which it needs to be, pentagon. So pentagon, n is 5. So if I want each interior angle, I'm going to take my sum formula, 180 times n minus 2, and we're going to divide it by n. That's the formula that we're using. So we've got 180 times 5 minus 2 divided by 5. All right, which is 180 times 3 divided by 5. So we've got 540 divided by 5 is going to give us 108 degrees. All right. The last problem in this set wants us to find the number of sides of a regular polygon that has an interior angle measure of 135. So it wants us to find the number of sides. So that's n. So this time they're asking us to solve for n. We know it's a regular polygon, and what we have is not the sum, but we have the interior angle measure, right? So the formula that allowed us to find that was this formula. So basically, they're saying, we're going to tell you what that equals. All right, whatever n is, we're going to get 135. That's what each angle is going to be. So we're going to take that formula and set it equal to 135. Again, treat this like a proportion. Pretend that's over 1. If we cross multiply, what we have is 135n equals 180 times n minus 2. So we'll distribute, and we'll have 180n minus 360. All right, I'll bring the 180 this way. So we're going to have negative 45n equals negative 360, and then we'll divide by negative 45. All right. And that's going to give us 8. Now it's not 8 degrees. We didn't find a degree. We were asked to find the number of sides. So again, important your labeling. If you're finding some of the angle measures, it's degrees. Each angle measure is a degree, but the number of sides, just write the word sides. Okay. So those are your interior rules. Let's look at the exterior. The sum of the measures of the exterior angles of a convex polygon, again, emphasize that word, corners have to be pushed out, one angle at each vertex, because, and I'm just going to use the triangle as our example, all right? An exterior angle, remember, has to make a linear pair with our interior. So there's actually 2. So that's why in this rule, it talks about that we're just talking about one exterior angle from each vertex. So the sum of the measures of the exterior angles is always 360. So it's not a formula, this is just a rule. So it doesn't matter if it's a triangle, quadrilateral, decagon, 130gon, it doesn't matter. If we take one exterior angle from each vertex and add them up, we will always get 360. So if you were asked to find the measure of each exterior angle, again, you're going to see that word regular, which tells you that all the angles are congruent. Then you take 360 and simply divide by n, the number of angles or the number of sides. So the exterior can be actually a little easier to do. So number 4, when it says find the sum of the exterior angles of a convex 14gon, it really doesn't matter what size it is. The sum is always 360 of our exterior angles. This says find the measure of each exterior angle of a convex 20gon. Well, then we start with 360 and we're going to divide by n since we want each. So it's just simply 360 divided by 20. And we're going to get, let's see, 1, 8. So 18 degrees. Number 6, find the number of sides. So it's asking us to find n, okay, of a regular polygon that has an exterior angle measure of 36. So you got to find all these keywords. So we're doing exterior angles. So this is the formula we would use to find each exterior angle. So we're going to take that formula and set it equal to 36. Again, just put it over 1, treat it like a proportion. So you've got 36n equals 360. Divide by 36. N is going to be 10 sides. Okay. So these are the type of problems that you're working. Again, read careful, underline those key phrases, sum, each. Make sure you know if you're doing interior or you're doing exterior. All right, if you have any questions, come see me. But this, you should be ready to practice the second worksheet.